So we have the question 3, part A1, define the term heat capacity. So what I have for this one is heat capacity is defined as the amount of heat energy required to change a substance or body by a temperature of 1 Kelvin. Right? The unit is joules per Kelvin. Right? Put that in red. Right. The formula for that would have been heat capacity is equal to energy all over mass. No, this has to be joules per kg, kilogram. My bad. Right? Because is energy all over mass. Right? They say to define it in specific latent heat of vaporization. So I have specific. Oh, that was looking like it's spelled wrong. Specific latent heat of vaporization is defined as the amount of heat energy required to change 1 kilogram of a liquid to a gas without a temperature change. Right? And well, we know the formula for that, well, for energy is mass by specific latent heat of vaporization. So LV would therefore be equal to energy divided by mass. So the unit will be joules per kilogram. Um, and you have a change in state, so therefore you do have a change in temperature, right? Now part B, a substance which has a freezing point of 80 degrees, which means that this temperature will be fixed, no temperature change when you have freezing occurring, was cooled from 90 degrees to a solid at its freezing point. Sketch a graph on figure 4 to represent this information. Now this would happen over a period of time, right? So when the time is 0, it will be at 90 degrees. After some time, the temperature of the substance will decrease to like 80 degrees. So we got it. Well, and it will remain at 80 degrees for a period of time because you have cooling occurring. So let's say was cooled to a total solid. So you have liquid and well solid will be down here. Right? So let me try to draw this graph here. It will look something like this. You have this solid being formed here. Right, this is like mixture of liquid solid. You have a change in state, no change in temperature, and but this is just liquid here. Understand this, right? Now, the next part, they say a student conducted an experiment which 1.5 kg of water at 30 degrees Celsius was converted to steam. Assume no heat is lost to the surroundings, calculate the amount of energy needed to heat the water from 30 degrees to 100 degrees. So we're heating up water from 30 degrees to 100 degrees, right? We have the formula E is equal to mc delta T. The mass is 1.5. The temperature change will be 100 minus 30. The specific capacity of water, look it down here. Some students just forget that data that's be given for these particular questions, right? And they don't use the data. Let's get confused. But the data that's be given at the bottom of these type of questions. So you have energy is equal to the mass, which is 1.5 multiplied by the specific heat capacity, which is 4,200 multiplied by the change in temperature, which is 100 minus 30. Right? Let me just write that out. 100 minus 30. So when you work out this in the calculator, what we getting? 1.5 times 4200 times 100 minus 30. Now this looking like 47. This is 4200, right? I am getting 441,000 joules. Right? Now part two, they say to convert the water at 100 degrees Celsius to steam. So we have liquid water at 100 degrees Celsius, and we converting this to steam. Same temperature, 100 degrees Celsius. So this is liquid, and this is gas. Right? So you have a change in state, no change in temperature. You're changing from liquid to gas. So we just learned about specific latent heat of vaporization. And look, they give me it here. Specific latent heat of vaporization of water is 2.3 by 10 to the power of 6. So we're going to use the formula energy is equal to mass by specific latent heat of vaporization. So energy is equal to the mass. The mass is 1.5 multiplied by the specific latent heat of vaporization, which is 2.3 times 10 to the power of 6. So we're going to get energy to be 1.5 times 2.3 by 10 to the 6. In standard form, I'm getting 3.45 by 10 to the power of 6 joules, which is basically 3,450,000. Right? That is what I'm getting. Now the third part, they say they want to know they want you to calculate the amount of energy needed to heat the water from 30 degrees Celsius to steam at 100 degrees Celsius. Well, you just add the two answers. So the total energy would therefore be Aperide 4.41 in standard, well, 441,000 standard form, 4.41 by 10 to the power of 5 plus 3.45 by 10 to the power of 6 joules. So the total energy, when we add them up, um, 4.41 to 10 to the 5 plus 3.45 by 10 to the 6, I'm getting 3,891,000 joules, or 3.891 times 10 to the power of 3 and 3 6 joules. right? So that's basically my answer there. Understand the solution here, right?